No.
Oh, that's what this is. What
That's Randy's application. Where's the restrooms?
You want to go back out through this door, and right when you came through the front door.
No, it's just this. And that's Vickett's building.
Just this. And I talked to Don McFadden. The Baldwin did the work. They have all kinds of stuff in here. Yeah. Let's see.
So links for the committee, these microphones need to get fixed and have the red light on. You want to speak into them. These ones in front of you guys are always on.
They are?
You don't have to do anything.
Good. Can you hear me anyway without them?
Yeah, so
It's for the recording.
It's
Oh.
it's for the recording only.
Mike. Good.
Up to you.
Want to start? Alright. You're good. We can go. You good, Amanda? I'm good. I'm sure. I guess so. Seems that way. All right. So, hi. Thanks everyone for coming to tonight's Mineral Extraction Committee meeting on Thursday, August 30th. We have some guest speakers here tonight to help clarify and answer questions around the mineral extraction. So, I think if we want to start with some introductions of the committee, we can start. Let's start with Reagan.
Hi, I'm Reagan. I'm a resident of Wyndham.
Yeah. And I'm Kathy. I'm also a resident of Wyndham.
I'm Sparky Urgent. I was on the Comprehensive Plan Review Team Committee and also on the implementation team. And now on this.
Drew Mayo. I'm a resident and on the planning board in Wyndham.
Hi, I'm Amanda Lassard. I'm the planner and I'm staffing the committee. So thank you so much for coming tonight to provide some answers to the committee's questions as we're working to draft some revisions to our mineral extraction ordinance and our land use ordinance. I think perhaps we'll let you introduce yourselves, but I think maybe just as a general kind of introduction, just to talk some about what the department's regulations are for gravel pits and quarries. And then on the agenda, we have some kind of general topic areas that the committee was interested in having some specific discussion about.
Okay. Well, introduce yourself first.
My name is Eric Clocker. I'm a mining specialist with the Maine DEP.
And I'm Mark Stevens, the Land Division Director for the Bureau of Land.
I'm John Hopek, a geologist with the Land Bureau and Water Bureau at DEP.
Do you want me to take the initial questions?
Go for it.
Just a little background about what we do and what we don't do. We regulate gravel pits that are anywhere from 5 acres or more in size. So our threshold for a state permit is 5 acres. So that means the actual hole in the ground, 5 acres. For a rock quarry, that would be a 1 acre threshold. Okay, and we look at all the disturbed area when we calculate that threshold. Both the gravel pit program and the quarry program, It's what I would call an alternative regulatory process. It's performance-based. And when I say performance-based, essentially all the standards are statutory. And essentially, the program just requires the applicant to submit a registration, what we call a notice of intent to comply, to the department. So it's more like a completeness review, but all the standards that they have to meet as far as groundwater, dust control, reclamation, blasting, all those standards are right specifically in each one of the statutes. Article 7 is for gravel pits. Article 8A is for quarries. We've been regulating gravel pits since 1993 underneath this performance-based process, and quarries since 1997. We do allow applicants to come in for what we call a variance. If there's a specific standard in statute that allows them to apply for a variance, they apply to the DEP. It's a formal application process at that time where there's public comment, there's public information. It's essentially the same process that any other project, say under the Stormwater Law or Site Law or the Natural Resources Protection Act, would require. For example, if a gravel pit wanted to excavate below the water table, the performance standard says 5 feet above. If you want to go below the water table, we require a hydrogeologic assessment. It's typically 1 year's worth of background. We evaluate what the impacts are to protected resources, impacts to adjacent wells, watersheds, river streams, brooks, all those sorts of things to see what the impact of that process might be. And we actually issue a department order. So that's been around since about 1997. That's kind of the gist of the mining kind of programs, but we do have other laws that come into play, like Natural Resources Protection Act. If somebody was building a road into a gravel pit or quarry, they had to cross wetlands. Depending on how much fill that they needed, it may trigger the need for a separate permit under some of the separate core laws that we have at DEP. That regulatory process for gravel pits and quarries, that was actually done by the legislature. Back in 1993, we convened a work group of environmental community folks, gravel pit operators, quarry operators, and staff members here at DEP, sat down and we worked out that regulatory process that you see in Article 7 and 8A. The variance rules, those are major sub-rules, so anytime that we make a change to those rules, we have to go through the Board of Environmental Protection, and then we have to go back to the legislature to get specific approval. So that's how that whole thing works. So they're kind of the oversight of some of those. Anytime we change a statute, obviously, we have to go back to the legislature to do that.
I'd just add that if anyone in here is familiar with the permit by rule process with the department, the process is similar for gravel pits and quarries. It's submission of data, it's reviewed by staff, and then it's accepted or denied. So it's not necessarily a permit per se, but by signing a notice of intent to comply, you're agreeing to operate under the performance standards.
That's correct. We have about 1,000 operations in the state licensed. Most of those are gravel pits. I'm going to say probably 850 or more gravel pits. The other 150 rock quarries, probably less than that. I'm going to say at least 130 quarries, clay pits, some topsoil mines. That's that kind of breakup.
Okay.
And if you need to see what's licensed in the state, you can go to our website, go to mining, go to Land Bureau mining. You can click on, we have a Google interactive map. You can type in any town in the state, and you can see what's licensed in the town. One thing I might add, we do not have jurisdiction in the unorganized areas of the states, like townships. So it's only for
organized townships.
So
yeah.
towns, essentially. So.
Okay. So I think we had a bunch of topics we wanted to try and jump in today. I think we probably have a lot of questions, I'm guessing. So I think if we jump right into our agenda, maybe the first item we covered was around blasting and the impact on abutting properties relating to noise, dust, vibration, and drinking water supply. So I don't know if you guys have any info or any input you guys can provide around those for us.
All right, John can help me out here. All our blasting, we'll just talk about the blasting standards real quick. Essentially, those are standards that were developed back in the 80s by the U.S. Bureau of Mines. Those are pretty much the standards that industry has used for that many years. There's been a lot of studies. Essentially, we have 3 different areas that we regulate under our blasting standards, and I'm going to go through each one of those. First one would be ground vibrations. Essentially, when a blast goes off, there's a wave energy that goes through the earth. We measure what that is, and at the closest structure, it has to be below 2 inches per second. So it's 2 inches per second. It's like I wish I had the diagram here. It's like a terrace thing. And the idea behind all these standards is the U.S. Bureau of Mines looked at what are the impacts to low-rise structures. So those blasting standards like ground vibration and air blast are designed to protect low-rise residential structures.
Basically, frame construction structures. What they essentially did was to do a variety of mechanisms that would shake these structures thousands of times, so that they could see what the damage thresholds were. And so when Mark is talking about the different plateaus and that 2 inches per second, that's the maximum amount for any frequency. For lower frequencies, for say 1 or 2 hertz, 1 or 2 oscillations per second, it's a much lower amount of energy involved because of the longer wavelength of those waves. What the Bureau of Mines found is that you're getting into a frequency where you can start racking the structure. So the higher frequencies, it just sort of is like that, but the lower ones, you can have one end of the building doing this and one end of the building doing that. And so when you get down to there, you're looking at half an inch per second or less for what the allowable energies of those. So it kind of looks the way you'd be looking at it. The low frequencies sort of come up, and there's a little rise, and then there's another plateau at about 2 inches per second.
And those have been pretty much standard since the program's been in. We have changed in the statute pretty much notification requirements for requiring the operator.
I want to clarify around the low frequency and high frequency, the 2 inch per second. So is that in elevation, so to speak, or is that horizontal impact on the building?
It's actually an acceleration. Mm-hmm. So what it is sort of the building may not actually move 2 inches, but it's sort of the rate at which the ground changes. If you averaged it out over time, you actually may be measuring a small fraction of a second, and the displacement in that 100th of a second or 10th of a second would be 2 inches per second, but in fact the displacement is much less. Simply having to do with how frequently the waves are moving.
Okay, the reason I ask is the potential for the locations are on higher elevations.
Oh, okay.
And so we're thinking about 500 feet, where the blast is happening is maybe at, say, 25, 30 feet higher than where my residence is and in the neighborhood. So, certainly being at a lower elevation may not be as critical, but then we're thinking again about the frequency, so it may not really impact. So I'm just trying to get a sense of that implication.
There are a lot of factors that would come into play in a case like that, and when Mark talks about air blast or air overpressure, we'll see what that gets. But when we deal with just the ground vibration, and if you're sitting at home, it's easy to confuse the two. But ground vibration is the actual energy that is transmitted through the earth to the measuring point or the sensitive location. Air overpressure is the pressure that's transmitted through the air to that same location. And when we talk about ground vibration by itself, there are a lot of things that come into play. How thick the soil is at your house, whether the soil is saturated or not at your house, whether your house is sitting in part or entirely on bedrock, what the orientation of the fractures are between your house and the source. So really they're things that we try to take into account, and if you read the blasting rules, one of the things that talks about there is that the operator should do what we call test blasts. to get a sense of, if the rock is not very well fractured in this direction, the energy may, the same amount of energy may travel farther, or be less damped traveling in that direction. But if the rock is fractured in this direction, well, every time the energy gets to a fracture, it loses some in making that jump, in basically the friction crossing that boundary. So that energy may not move out equally in all directions. And that's something we have the test blast program in there to have the operator take that into account.
I think the best way to describe sort of what a blast is like is if you just take a pebble and you go out to the water's edge and you throw a pebble out into the pond, and you see how when it hits the water, you see all the waves, how it dissipates out, and it keeps going and keeps going. Sort of like, just like a blast. I mean, as that wave energy goes, it's going to start to dissipate the further you are away from the shot. I think the key here with a typical blast is right around 20 hertz, 20 to 50 hertz. It's up on the high end, so it'd be closer to that 2 inches per second. The place that we get really concerned is when it's a low frequency, like 4 to 12 hertz, which is, it sort of matches the resonance of your house. So if I told you your house was moving, you'd sit there and say no, but it actually does vibrate. And the idea is sometimes those wavelengths match, and you get a larger kind of a shaking in your house. And that's why you have that half inch per second for those lower frequencies. And it's really designed for sort of the old construction type houses, plaster and lath construction, something really old. And when we're talking about protection, we're talking about cracks that are truly cosmetic. It's not like it's going to flatten your house. It's going to be these cosmetic things that you may see above your doors or your windows, because as John said, it's kind of a racking motion. So usually when you see the cracks, they're usually in a pair. It's the old physics saying, for every action there's an equal opposite reaction. So you'll see that. We do require, as part of the blasting operation, that they do pre-blast surveys of houses. Essentially what that requires is somebody comes in with a video camera and they do an inspection to see what you have in your house now. Where are the cracks? Where are your sheetrock screws popping out? Do you have any loose mortar around your chimneys? Those sorts of things, so they have a baseline to document stuff. And then if there's an issue or a complaint, you can go back and look at that, and then we pull all the blast records, and we look at the design of the blast, we look at the levels that were done. We actually, most of the time, those blasts are videotape, which can tell a lot because we can see a lot. You can break that right down to see exactly what happened. As far as, for example, I talked about ground vibration first. The next thing would be air blast. John mentioned that was, you got the wave going through the earth, then you got the energy wave traveling through the air. Okay? And a blast, just to give you the idea, the typical blast is 1 second. So the whole blast event might be 3 seconds by the time the air blast hits the first protected location, because it travels slower through the air than the wave going through the earth. And we have standards. It's measured in PSIs or decibel levels. And that's sort of like, to give you an idea what that sounds like, it's like if you're sleeping in the middle of the night and there's a wicked thunderstorm and you have a big clap of thunder and all of a sudden all your windows rattle in your house. That's exactly what it's going to sound like when it hits the structure. And those, again, are designed to prevent structural damage to the house. Like windows blow out at, typically, it's like 170 decibels. Your normal air blast is probably 120 to 129. It's a logarithmic scale, so remember that when you combine those energies. And the third thing we look at is what we call fly rock. And it's exactly what it sounds like. It's rock that actually leaves the blast site, okay? And it can depend on how the shot's designed, because they're timed, okay? Not all the holes go at one time, okay? So everything is sequential. They have a start point, and there's milliseconds between each row before it goes off. Because if it all went off at once, you definitely would know it. So each one is timed. So one hole is going off, 8 milliseconds later, the next one's going, then it goes in succession. And the idea is to have that front face of the rock move first, and then the next row behind it and the next row. If the front face doesn't move, the next row of holes and rock has no place to go but up and out. And typically that's where you run into problems with fly rock going off site. And does it happen? Yes. Does it happen often? No. Have I seen damage from fly rock before? Yes. Probably, I'm going to say less than a dozen cases that I've seen over the last 29 years. I've seen rock go as far as 1,000 feet. You know, depending on how it's designed. It's all based on. Say it again? 1,000 feet. Yep, that was a really bad blast design. It was real easy to see too, because when you looked at the quarry face, there was like a big divot, just like you were golfing. Everything's flat except for this one spot. And essentially what happened, they calculated the pounds per hole per delay. They base it on how much rock's in front. Typically it's a 9x9 spacing, so that means there's 9 feet of rock in front and 9 feet of rock behind. Well, when you take to drill a hole, take your finger and push it down the table, it kind of bends. So when you're putting steel through rock, sometimes that drill wanders. So you're thinking you got 9 feet sometimes, and when you get to the bottom of the hole, which is typically a face of a quarry, might be 50 feet, 55 feet, you might only have 4 feet, but you're loading for 9 feet of rock. So in that case that it went 1,000 feet, it was really simple. They only had 2 feet of rock in front, so all that energy went and threw the rock outside of the quarry limits. So it does happen. I've seen some structural damage, and that's a real easy one for us. Fly rock, when it goes through a roof or through a window or through a wall, you can't mistake it. It leaves a hole.
And that's also those same problems are also where you see your air blast problem. You think about it that there's so much energy in the explosive, and some of it is no matter how perfect the blast is, some of it's wasted as air overpressure and ground vibration. But you want to maximize how much of it you use to fragment the rock, because that's simply a cheaper way to operate. But these are very easy to see in, as Mark is saying, when that energy is not used for something else, it blows the rock up, and that pressure wave is often what gives you your noise complaints. Also, in addition to the fly rock, even if the rock doesn't leave the site. And that's really easy to see on the video, because you're looking at the video and you'd expect to see the dust and stuff rise up. But if you see 1 or 2 holes that just cannon up like that, there's a problem either in the timing. The idea of the timing of the holes that Mark is talking about is basically you let the energy from one hole clear the area before the next one goes off, so that you're not adding the effects of them. But if you've done your timing wrong, that will show up in the chart, in the timing chart, and we can find those pretty easily. But sometimes things happen. One hole will set off another hole, even if they're too close together. But you'll see that in the video. And then there are things you can't. Again, going back to what the rules specify, we want the driller and the blaster to coordinate with one another, so that if the driller finds a particularly tough zone or a particularly weak zone, well, that could affect how you design that particular hole. If you encounter a zone that's drilling really easily, then you tell the blaster that, and so that he or she will know, well, while I'm loading that section, when I get to that part, maybe I don't want to load as much explosive in there. Maybe I want to put some inert material in there, because that part of rock is already pretty weak. Or conversely, the driller might find a zone that drills very slowly and might tell the blaster, this is fairly tough stuff. You might want to deal with that differently, so that you don't get either big chunks, or that you don't get, because it's very resistant, the blast energy blowing back up the hole.
And Mark touched on it briefly about steel bends when you're putting weight on it, and that's typically why a quarry face is only about 50 feet, 45 to 50 feet, because after that, at that depth, the rods start to wander and they'll walk, and you lose your spacing
and they actually can track that too. Some companies use what we call bullhole tracking, depending if they have a lot of wander in the drill, so they can actually, it's a GPS thing, they can go from the top of the hole to the bottom, and it's like a little plot that you see, and you'll see where it's supposed to go, and then all of a sudden you'll see a dash line. It might be circling, says 2 feet So you know you're 2 feet. You started over here, but now you're 2 feet left or right. So you're like, okay, we got to do something different here. There was a question right here, if I recall.
Yes, you mentioned before measurements around the blast, and I'm just wondering if you feel that we need to protect the drinking water supply, specifically lakes or streams that are feeding into larger bodies of water, and that actually would feed our population in terms of the water supply. So I'm wondering how far these blasts should be from that drinking source, just so that we can protect.
Let me just take that in a generality, and then Eric and John can jump in. Of course, we have the blasting standards, and there are other standards in the rule that deals with protected resources, as far as setbacks to like private water supplies, public water supplies, great ponds, rivers and brooks, 100-foot setbacks to property lines. We have requirements for fuel storage. Essentially, if there is, it's a secondary containment structure, spill prevention, just your normal basic stuff, so you prevent those kind of issues that may occur to impact, say, water quality. Most of the blasting issues, like I said, are typically designed to protect structures. It's not really designed to protect water quality. I mean, most of the explosives and stuff are burnt up in the actual shot itself. I'm trying to think of some other setbacks that we have.
There are setbacks from oil.
Yeah, I think I got them right here. Let's just look at this. Oh, let's see if I can look at this real quick. This is a little cheat sheet I made a long time ago. Eric, you've seen this one before.
And I was reading through your draft rules, and it mentions protection of water quality. And what I would recommend as part of the pre-blast survey is maybe providing a water sample to the lab to get a baseline, so that you actually know that if something goes wrong, you might have a clue as to the issue there. So that should be part of the upfront before anything begins type of process.
No, I completely agree with that. We already, at this point in time, we already have 5 bodies of water in Wyndham that are considered threat right now. So I'm wondering, then they should not be disturbed additionally through this blasting process, through any type of waves that could hit that body of water. And so thinking about 800 feet away from a shoreline, so what are the numbers? 500 feet, 1,000 feet? So I'm just concerned about those 5 bodies of water that are already broken or ill at this point in time, if you will. They're already in a threatened situation at this point in time. So that standard is for healthy bodies of water. But I'm just thinking about those that are already threatened or endangered in some way. That's one of our greater concerns. So I understand that standard is applicable to those waters that are healthy or doing well, or those that are trying to maintain, those that are threatened at this point in time. There should be a difference in that standard to try to protect those waters. Are there any recommendations that you can offer around that at this point? Because I'm finding that we're seeing so much literature about waters that are healthy, but what about those that are at risk?
Let's just talk about some watersheds at risk, and let's just talk about some of what the performance standards are. Say you have a gravel pit or quarry. One of the performance says you got to drain internally. That means everything on site has to drain internally. If it doesn't drain internally, that means it's going to drain externally. And the rule doesn't allow that unless you come in for a variance. So when it comes in for a variance, we look at what kind of designs or stormwater measures they take to protect water quality. For example, if that pit or quarry was in a watershed most at risk, obviously we use our stormwater standards. There's a phosphorus standard. All those calculations are taken into account when we look at the engineering and what kind of best management practices they're using to protect water quality in that watershed. So the standards are the same for either a gravel pit or quarry. If you drain externally, you got to meet our stormwater standards, which is the same standards that we require for subdivisions, residential subdivision, commercial subdivisions, anything that's. So I mean that's how we kind of we got these basic standards, erosion control standards, general standards, and we do have phosphorus standards. And we also have urban impaired standards, and I'm not, urban impaired streams in England?
No.
Not that I could think of.
None?
No.
That's a good thing. So I'm trying to think with the phosphorus, that would be the one if they were draining externally. And we do have gravel pits on quarries and watersheds most at risk. And they do have variances that are issued, and we do the same kind of standards that we use for any other project coming through DEP for review.
And the access roads would have the same, as the gravel roads, we would treat it as a gravel road as if it were a camp road or any other water quality standard would, or the same BMPs would apply in that case.
And a lot of times that's use of like stormwater buffers, woody buffers, which we require buffers anyway, but it could be a larger buffer where stormwater is discharged through like a level lip spreader. I don't see too many infiltration stuff for gravel pits and quarries. It's a little different. It's a different kind of, I won't say, it's a different type of industry than like a commercial or residential subdivision, okay? So you're talking about commercial, you're talking about pavement. When you're talking about gravel pit and stuff, you're talking about haul roads. Some of those haul roads are temporary. You got rock, which is really impervious. It's a little different than asphalt, but we still treat it as impervious. So we're looking at all that water coming off there. Where does it go? Trying to think off the top of my head, I'm trying to think of how many variances we issued. Maybe 70, 65.
I've written a couple.
Yeah, variances to drain externally. The idea is to keep everything on site. So with a gravel pit, it's pretty easy because you're making a bowl and everything essentially goes to the bottom of the bowl, infiltrates. With a quarry, sometimes it's a little different because you're typically on a hillside or you're shooting down below grade. Just typically groundwater, I'm saying 20 to 30 feet is your typical range before you hit groundwater in bedrock in Maine. That's just an average. I'm just throwing that out there. And for a quarry, the separation is you can't go into it. It's not a 5-foot separation like gravel pits. It just says you can't go into the water table. So when we're on site, we actually measure if they have monitoring well. We have a little meter, kind of tells us where it is. And trust me, when you see it, it's very obvious. When you sit there and you look at the quarry, you're looking down at 7 feet deep, you're like, well, that's definitely not stormwater. It's groundwater. So,
and they've actually proposed using the gravel pit standard for quarry as a 5-foot separation.
Yeah.
For their ordinance, so it's more stringent.
More stringent than what the state would have.
And many Maine quarries don't operate constantly. They'll operate for a period of time and build and stockpile material, and then the operator will move the crusher to a different location, or they're not blasting constantly, so they may just do a couple of blasts and build up material. So in between, they may accumulate precipitation, and if we're thinking about stormwater impact, then what happens to the water that's pumped out of the quarry when they go back in 3 years or 5 years or however many years it is to start operating again? Well, that's something you would want an operator to make a provision for, and that could be done with spray application in a wooded area. It could be done with pumping to level lip spreaders or buffers, but basically you would treat that similarly to how you would treat stormwater.
For the variance?
Watering? Yeah,
Oh.
no, dewatering of.
It's essentially, it says you can't go into the water table without a variance.
Right, but as far as dewatering precipitation that accumulates.
You typically,
It would be because it's a discharge, it would count as a non-externally drained.
Okay.
That would be a variance for that then?
yeah, if you were pumping out, yes. If you were pumping the quarry out to get rid of stuff, that's externally drained in our books. So you would have to have some other type of license to be governed.
Do you, going to blasting, you mentioned water samples and so forth, but in your analysis or your study of a test blast and stuff, do you have a way of determining if the blast would impact an artesian well in terms of lessening the water supply to it, or if you open up a fracture and then that water drains away, or is that totally off base?
It does not take a very big change in the dimensions of a fracture to have an effect on the yield. what we find in practice and what's consistent with other locations is that you have that to have that sort of change take place, to actually sort of be looking at the dimensions of the fractures, the well has to be very, within a few hundred feet of the quarry face. Mm-hmm. Outside of that, again, it feels like a lot of energy when you're standing there, but if you think about the amount of energy that would actually be required to physically damage the rock, it would flatten the house before you got there. Now, what can happen? There are two things that can be issues. Well, three if we count the spill prevention stuff, which is a separate thing, but just relating to blasting and use of explosives. There have been problems not in Maine, but in New Hampshire, due to poor storage of explosives and poor disposal practices of explosives waste, essentially the boxes that the explosives come in. They have had a problem with nitrogen leaching into groundwater, and that was a big construction project on, I think, 202 from 10-ish years ago. From talking to the New Hampshire DES people and looking at the site, that was a very big, long road cut that they worked on, and it was just poor handling of explosives and explosive waste. The fire marshal's office has rules that deal with storage and handling of explosives, and again, if someone is following those, that wouldn't be a problem. I mean, a construction project where you're doing blast after blast after blast after blast, they're going to store on site. Most quarries in Maine contract out, have a blaster come in and brings in just what they need to do what they want. Now, one thing that we do see is that the vibrations don't physically damage the wells, but anyone who's got a well in Maine knows that it accumulates sediment on the inside, and you can have vibrations that are not sufficient to do any damage to the well, but can shake it enough to loosen up some of that sediment. So we do sometimes see a change in the turbidity of the wells following blasting at some locations. It's not systematic, but obviously the closer you are, the bigger it is, the greater probability there is of that occurring. So turbidity is a very common pre-blast and post-blast test for wells that are close to quarrying or other types of blasting operations. We've done them for blasting at wind farms too. But again, it's not physical damage to the well. It's that the nature of the water in Maine is such that it has a lot of iron, it has a lot of manganese, and a lot of other stuff in it that will precipitate out in the well. And if you shake it, some of that can come loose from the inside of the well or from the pipe or something like that. We do sometimes see that.
Yeah, a lot of domestic wells have filters and stuff for iron and manganese, these little blebs and stuff when you pump. And we have hard water, so we have softeners. A lot of that in bedrock here in Maine.
You recently mentioned stormwater runoff. Mm-hmm. If a quarry is in terms of elevation, higher than these 5 endangered waters, and there is stormwater that's run off into the lake because there's no other area for that water to go. So it'd be interesting, specifically on a camp property road, is not a main road. I'm wondering what the risk could be and if it's elevated in some way. So I'm wondering if DEP has ever considered which places or which specific quarries or pits versus some places that have less risk. So I know that we're thinking about those explosives, we're thinking about fuel, storage as well. If we're thinking of that, considering there's also drinking water within that area as well. I'm wondering if those would be areas that have more risk as opposed to other areas that are safer.
I mean, the standards are pretty much designed to, they're general standards, okay? So we don't have specific standards for different situations. I think the standards have worked over the last 25 years just based on what we've seen and our analysis. And just getting back to water quality, I mean, our standard has something really simple. I think I saw it somewhere in your ordinance where you require some kind of surety bond that deals with water quality. If a well is knocked out, you require some upfront cash. Essentially, our standard says is if you knock somebody's well out, you go in and replace it. That's what the statute said. If you knock it out, you got to put something back. That's simple. As far as whether it's a watershed, I mean, really, the key to watershed issues is could be some of the existing development in the area. I mean, we're talking about fuel storage, but say if you're looking at a place that's highly developed, each house may have fuel storage. Typically, it's a 275 in your basement. Some houses have outside kerosene tanks. Those things certainly are mostly single-walled tanks. They're not double-walled. I mean, the safety precautions that we have is if there is on-site fuel storage, how much there is, and it requires secondary containment. Sometimes they refuel mobilely by back of a pickup truck, which is typically maybe a 60-gallon tank. Will have a spill kit in the truck, because you don't typically see catastrophic failures of tanks out there in quarry operations. Typically, what you see is like an overfill or something like that. A valve is left open. Hydraulic line breaks.
Equipment.
I mean, mostly that's probably the biggest one is when you see, because equipment breaks down. It's just like your car. It's going to break, and wherever it is in that quarry on the road, it's going to break. And it's how you prepare yourself to handle that. What do you do to stop that? So, I mean, those are all requirements, because our variance rules has like a SPC requirement in there to have, shovels, absorbent pads, all that stuff. I actually had some really good slides. I wish I could have brought them all here tonight for fuel containment and that stuff. I could take you right through nuts and bolts for what a typical quarry or gravel pit looks like and what you might see in there, because it's different. Depends on the size of the operator. What they got, you could have your mom and pop down the road that's just a front end loader and a dump truck, and you could have somebody as large as Chevrolet that has the whole crushing facility, or you could have a Pike that has crushing facilities with asphalt plants, because the idea is they're making a product to sell, and they're also making road product for asphalt, those sorts of things. So you can see a variety of different types of processing equipment in there.
Can you share those with us? Can you send them to Amanda to share with us?
I can send you some photos. Can you write that down for me, Eric, so I don't forget? Because I know
I probably got some myself.
I know you do. Eric's he's the primary field inspector now, so he's been to pretty much.
It's been to about 500 sites.
500 sites. And I've looked at, there's not too many that I haven't seen in the state. I mean, now my new capacity, I don't see them as often. Once in a while, Eric saves me and takes me out in the field. But I've pretty much been to everything that's been licensed in the last 27 years, all through the state. So I see a bunch of different things. Kathy?
How often do you check these quarries?
That's a great question. By statute, we are required to at least do an inspection every 3 years. So we rotate. So essentially, if we do an inspection, that next inspection will be 3 years later, unless we receive a complaint. We get a complaint, that's automatically on the list to go look at. Okay? So when you're talking about 1,000 operations, and we cover from Kittery to Rangeley to Eastport all the way to Fort Kent with 2 people, that's a lot. One at the moment, because your boss deserted you.
Yeah.
It's a lot. I think the best we have done for inspections was 2017. We did 315 combined inspections, and typically you have a short field season because roads are posted in April and May. Some of these operations aren't really getting going to Memorial Day weekend, and they run maybe to the first week of December. Some of your processing facilities will shut down, like asphalt plants and crushing, because once it gets cold, you can't use water suppression for dust anymore, so everything has to be shut off. So you have 6 months that stuff doesn't work. That's why you have these. They shoot a lot maybe in the summers because they're building a surge pile to get them through that construction season. But we do it once every 3 years. I think if I read your ordinance correctly, I think your CEO goes out on an annual basis. Am I correct?
That's what we're proposing. That's not our current standard. Right now, we just have a process.
And a lot of towns do that.
It's just a 5-year, give us your working area for the next 5 years.
A lot of towns have that requirement, and some towns that I've seen, mostly down here in Cumberland, New York. Now I'll tell you why in just a sec, but they require engineering company or a third party to go out and look. And the cost is that inspection is paid by the applicant as part of that fee to come through the local process. So that's always, and we've actually done training sessions for CEOs in the past for gravel pit inspections. I think we just did one down.
Did one in Brewer.
Did one in Brewer, and we did one in, I think it was in Wyndham at the fire station on 302. It was all the CEOs.
No, it was Raymond.
That was Raymond. Yeah, on 302. So they had a bunch of CEOs from the region. But here in southern Maine, I'm going to tell you, probably have 40% of the pits licensed in the state. Why? Because southern Maine is busy and everybody wants to build stuff. So most of those licensed pits are in Cumberland, New York. You go to Aroostook County, I might have 65 licensed. You go to York County, 155 licensed that we look at. So
we actually are proposing a third-party annual inspection of the stormwater
stuff.
Yeah.
Yep. And if you're looking at something like that, it's easy enough to just require the whole thing to be looked at. So that would be my suggestion. If somebody's already going out and looking at stormwater features, if it's internally drained, you're not going to see a bunch of structural controls. You're going to go and say, does it drain externally or externally? It's a yes or no thing. But if you're going out to do a compliance inspection, you've got separation of the water table, check your buffers. What do you use it for dust control? What do you have for fuel storage? What's the reclaimed slope look like? What's the vegetation cover? All those things. Are there fill areas? Are you burying stumps on site? Are you chipping stumps? There's a whole slew. We have a huge inspection list that we look at, and I can certainly send that to the town too, what our checklist is for inspection. It's pretty comprehensive. I mean, we, as a unit, we cover a lot of different programs in DEP. Solid waste, fuel storage, which is remediation and waste management. NERPA stuff. It's a whole slew of things that we look at. And we have a question here.
Do you have any recommendations, for example, if you know that you have repeat offenders, a business perhaps that is not following the standards or the regulations, and they continue to do that over and over? So, for example, Wyndham has felt limited in that they were not able to decline a plan for their next proposal, or pit or quarry. So how do you feel about that? Like, if we know that a business is not responsible or good stewards of the environment, and they continue to violate that, how can we prevent them from having subsequent requests for licensure?
That's a great question too. First, it is difficult. And do we have repeat offenders? Yes. The only time that I think that we can take the compliance history of an operator into account is when they come in for a variance. We can look and see how well they've done. If they're a repeat offender, they don't get the variance. If we have a repeat offender, I mean, obviously we have the enforcement capabilities here at DEP, and something that's very unique to the mining program is that we are probably the only DEP program where we actually have statutory stop work authority. Okay? And we have used it on occasions. Depends on the size, the nature of the violation, what's impacted, but we can issue a stop work order. Unlike if somebody violated NRPA or site law or stormwater, we do not have that ability to issue a stop work order. We have to go get a court injunction. Right. So that's a really key tool if you have that in your ordinance. So if you haven't got something in there, that might be something you might want to consider.
We did add around, what was it? We would be able to, if you had an applicant had an open permit in the town of Wyndham, we'd be able to with a violation, we would deny based off that. I think probably what Regan you were getting at was more around if they were in Gorham and applying in Wyndham, we necessarily wouldn't be able to take that.
It is hard though, because a lot of the larger operators have multiple sites because they do work in multiple areas of the state, and it's really all about distance, trucking distance. The further away you are from the job site, the more it costs to get that material there. So they're really so they want to get sites all over it, wherever their work area might be. I mean.
So you don't stop it until it actually occurs. There's no prevention prior to.
No, the only thing I had, like I had mentioned, was for the variance provision. That's if somebody came in and requested a variance, we look at the compliance history. And I'm trying to think off the top of my head.
I just had one.
I'm thinking, one or two variances that we have denied based on the compliance history. So doesn't happen very often, but it does happen.
If other municipalities are affected by this particular person, shouldn't that come into play?
Like I said, ours is all statutory, so to change ours is a little hard because we got to go to the legislature and have that discussion. With the town, I mean, you have a lot of authority under home rule, and you can probably put stuff. You just want to be really careful that you don't put yourself in a corner that's hard to get out of.
Right. That had been the conversation with the attorney, is that, without a comprehensive listing of violations that we consistently were reported in the same fashion, there may not be equity among project review, and that's really the concern.
That's the key.
The planning board does have the flexibility, even without that proposal, to not approve a project if there's an existing violation in Wyndham, that in making a finding of an applicant having technical capacity to do a project, that some consideration could be given that if they are not successfully completing past projects, that they don't have the technical capacity. But to my knowledge, that hasn't been a reason for denial locally. But I think it could be something the planning board could consider, but that would be a case by case.
Yeah, I mean, we don't even have any standards in other laws that says if they're violators, we can't issue a permit. As if they meet the criteria in statute, then the permit's issued.
Metallic mining, maybe.
That's the only one. Metallic mineral mining is the only one. Okay, when I say metallic mineral mining, it's lead, copper, zinc, gold, that kind of stuff. I think that's the only rule where we look at the compliance history of the operator. So that's the one example we have. A gravel pit and an aggregate quarry is totally different than a metal mine. It's like apples and oranges as far as potential impacts.
We've been kind of circling around this groundwater, surface water quality question, and I think we've had a couple questions on understanding those impacts has something to do with understanding kind of recharge areas for lake watersheds versus aquifers. Could you maybe give us some education on kind of, I know there's mapped areas for aquifer boundaries, there's mapped areas for watershed boundaries, just sort of kind of the difference between the two and how water gets from, and is there a connection between that lake water and the mapped aquifer?
That's a loaded question. I'll let you have that one.
Well, I mean, the short answer is yes.
There you go.
It will vary from site to site, and certainly your initial assumption would be that the surface watershed and the ground watershed would be similar. That will break down very quickly as you get to smaller and smaller areas, and particularly when you're dealing with sand and gravel, the subtle variations in topography that you see may have no bearing whatever to what's happening with the groundwater, or they could be fairly significant. That's what's critical for us is looking at the number of explorations and that those are evenly distributed throughout the area, and sort of documenting what are the critical receptors. In gravel pits, it's pretty simple because everything is connected, and we sometimes do look and see things that become critical are whether or not there's a wetland that might be receiving water from the pit. Often in some of these gravel pit settings, there are wetlands that are perched, that they were in low areas that just accumulated organic matter over 5,000 years, and so now they tend to collect water even though the water table's quite a bit below them now. So it becomes important how the pit works around those, if those are to be maintained rather than affected as part of the mining operation.
I would just add also that main statute, all groundwater is classified GWA and shall be suitable for drinking. There are issues that you have, iron, manganese, that come up, but ideally under statute, it is GWA standards.
Yep. But the statute has a provision that says except as naturally occurs. So we know. So if you are dealing with an area of Maine that has arsenic contamination, deal with a toxic one or just an aesthetic one that may have high iron levels, then the way we apply that is an operator of any kind of facility. We recognize that it already doesn't meet the standard, but the operator is obligated to not make it any worse than it is. And the fact that it doesn't meet the standard for arsenic doesn't make it okay to not meet it for benzene. The benzene standard still applies even if it's non-potable because of arsenic.
Follow-up question on what you were just talking about with the groundwater, the GWA. So you're saying if the water is not meeting the standard and they basically, the business cannot make it worse, wouldn't that be similar to the idea of our 3 bodies of water who currently are threatened and don't meet potable standards or whatever? I would think that you wouldn't want it to make it worse by having these gravel pits.
Surficial standards are different.
Yeah, you also have, surficial, you have an anti-degradation standard that comes into play. The surficial standards are certainly more complex than the groundwater standard, and I think take into account more the fact that.
Can you go back to the start of that for me?
Sure. The surficial standards are more complex, and I think it's assumed in the superficial standards that you're dealing with impacts from point discharges or non-point discharges. The groundwater standard is kept fairly simple. Why gets into the whole history of the Clean Water Act and some other things we don't need to go to, but the groundwater standard is very simple. But we do have to deal with the fact that as naturally occurs means naturally occurs, not a case where you have a stream that's degraded because of an impoundment on the stream or a waste discharge to the stream or something like that. It means that if there were no human beings on the planet, this water would still not meet the standard for arsenic or iron or whatever it is. Whereas a stream may have, and it's an assumption that's baked into the law, a stream may be dealing with an anthropogenic problem. Now, that's not always the case. There are a great many streams that would have terrible water quality and would not support a diverse habitat if there were no humans on the planet. But that's something we have to work around when we do the classification for stream. And for surface waters, the classification just is a more complicated system.
Clear as mud, wasn't that? It is. The water quality laws are very complex and they're all intertwined. So, when you're thinking of like water bodies, rivers, streams, or brooks that have existing water quality issues, the idea is not to exacerbate those. And that's where you look at those standards are. Typically, when you look at some of these lakes that have issues, it's the development in that whole watershed, how much development has occurred. Typically, it's the phosphorus load. It could be, there's some lakes I know in central Maine that a lot of agricultural next by. Those are huge exports of phosphorus and some other stuff, nitrogen through manure storage. So you have to kind of look at everything in that watershed. I'm trying to think. We do groundwater monitoring. We have done some limited surface water stuff, but with the setbacks and using stormwater controls and BMPs, the idea is that water quality is not going to be degraded. So that's the premise there. If you can design using those BMPs, that water quality should not be further degraded.
Right. It's mostly an issue for the mining side of things. Unless there are specific wastes or something associated with the project with dealing with quantity. So if you have drainage across the site, or if you have more commonly with a quarry or something that might be depressing the groundwater table while it's operating, or with a big gravel pit. You had a water table that was sloping across the site beforehand, and now when you make it a pond, it's obviously flat. Where did that water go? Was that water going to a stream, and do we have the monitoring keyed into how that stream is behaving to know that it's not having an effect, or if it is having an effect, that triggers a phase in the operation where the applicant has to do something to restore the flow to that stream, recognizing that the volume of water seasonally is an important part of maintaining that water quality classification.
Oh, good.
Okay, I'm still thinking about this and thinking about, you had mentioned the stream. So I'm thinking if a quarry is 55 feet higher than a threatened lake, and there's a stream that feeds into that lake, and the lake feeds into a larger body of water, say the Penobscot River, and then that goes into 80,000 people population-wise of drinking water. So the idea is not to make it worse or is a situation, but we're looking at 800 feet. This quarry is 800 feet from the water. So I feel like it's a high risk traffic area. The trucks are 500 feet from the water line, and they're coming in up then say 50 trucks a day. So I'm again concerned about the 5 bodies of water in Windham for our future generations. We want to make sure that the water is acceptable. If we can't protect the water that is already threatened, we have banned some agricultural things, looking at the aquifer overlay zone to make sure that we do have water for the future. Then I'm thinking, what would be the point of having the DEP if we're not able to preserve the water at this point? Something that's already threatened and we're not even looking to put into place protections. I think, again, the standards are perfect for areas of water that are already okay, but if it's polluted or at risk, for example, the subdivisions should not be put in those areas. Agriculture should not happen in those areas. No mining. I guess what can the DEP do to help us if not protect the water?
I think essentially, if I'm hearing you correctly, in order for that whole, say, a lake most at risk, you'd almost have to say no development anywhere in that watershed. Nothing. No homes, nothing. So no development. So you'd almost have to close it off. I mean, that's, if I'm hearing you correctly, you'd have to close it off. I mean, if you put a subdivision in the watershed, that impacts, or our exports, how does that impact? So if you wanted no additional impacts, then the only thing you could do is say there's nothing going on in this zone at all. So if you're looking at a lake watershed, it's somebody comes in for a home, that would be a no. Somebody comes in for a subdivision, that would be a no. A Rite Aid wants to go down in the corner on a main street that's developed, that's in that watershed, that would be a no too. So I guess that's the only way I would look at it.
Well, there's also
And overdevelopment.
I was going to say there's a difference though in how different types of development have to treat their runoff.
Right.
A lot of development that happens in these watersheds most at risk don't treat anything because they don't rise to the level of permitting that at that DEP level of permitting that requires meeting the stormwater rules, or in Windham is not a site plan or a subdivision that requires meeting stormwater rules. So that's a separate issue. I think what maybe everyone is not at the comfort level that projects of this size, that the BMPs that are required are adequate to protect the lake.
Yeah, and with any quarry or any gravel pit, you might start at this elevation here, but by the time you're done, you're going to be down at this elevation. So if I have a knoll that's 60 feet high and I'm blasting rock, that 60-foot knoll is going to be down here. You may have, when you start, the lake might be here, but when you're done, that quarry is going to be down here. See what I'm saying?
And again, I would, in this particular instance, in general, the quarry has to be internally drained anyways. The only stormwater runoff you're going to have from this site is off the access road.
So where does that groundwater Go.
Well, they have to stay above it, so there is none. You have to stay.
Still,
you're
but the
within
water
5 feet
that's
above it.
but the water that's been internally,
it's soaked
it's
through.
going
It'll
into
soak
the
through
watershed.
fractures.
It's still going into the watershed.
But it's been filtered by the time it gets into the watershed.
Not transmitting nutrients to the surface water or groundwater.
It's doing the same thing it's doing now. It's infiltrating into the groundwater system.
Yeah, I mean, to 2 points. And some things will change because you may be taking a slope like that and making it flat or internally drained. So you can argue that there will be more or less recharge depending on exactly
Yeah,
what the
my
final
biggest
configuration is gonna be.
concern is that road.
So it's not. The other is sort of what is there something unique about let's just pick a number, 40-acre quarry operation compared to a 40-acre shopping center in terms of the quality of runoff that's coming off? Is it worse or better? Do you have particular contaminants that would be coming from a quarry site, even one that's externally drained, that you wouldn't deal with coming off pavement, roof runoff, active roads areas, salt storage? I think that the thing is that if you're dealing with, if you're focusing on the stormwater practices, what about them? What is unique as you look at that about a quarry as an industrial development compared to a commercial and another type of commercial industrial development that had traffic, asphalt, pavement, features like that?
I guess I want to clarify a little bit more because I feel like maybe my comment wasn't fully addressed. So maybe I'll try to phrase it again in a different way. I agree that there should not be any more development close to that lake that I'm thinking specifically of. But I'm talking about, stopping it from here on out as far as a critical mass level that I feel like it's been met. But I'm just wondering why DEP cannot protect the water from subdivision development, quarries, gravel pits, and so on. For example, we can't have chickens in our front yard if we're abutting the lake. I'm not sure why you would permit a quarry to be, within 500 feet, especially when it's on a ledge that's higher, when there's going to be runoff. Again, those 5 bodies of water are at risk. So I want to know what DEP is going to do to protect that water that we're going to need and for subsequent generations. We don't want any more development in that area. It's already too close to the water as it is. So, and I guess I'm just wondering from today, August, what's the date? 30th. Heretofore, what DEP can do to protect those 5 bodies of water. Because last year we tried to stop those subdivisions and there were 30 new houses that were put in close to the lake, and we protested and it seemed like nobody cared and no one cared about the water quality as a priority, and we complained and nothing was done until there was a violation. We don't want to do the guinea pig. We don't want to wait until after it happens. We want to take preventative actions and using our common sense rather than regulations and I guess, that type of thing.
Thank you.
I think it's a joint effort. At the beginning, I talked about thresholds. We only cover gravel pits 5 acres or more in size. So anything less than 5 acres, we don't catch. Rock quarry, 1 acre or more. Anything less than 1 acre, we don't catch it. And you have a very small one in the same vicinity in Forest Lake watershed. Talk about subdivisions. For the DEP to regulate a subdivision, it has to be at least 15 lots on 30 acres. We're not going to catch these subdivisions that are 4 lots on 10 acres. We don't have that ability to catch that. So, you got some projects that we're never even going to see at a state level to address some of these concerns. If the project's big enough, the idea is that we have those rules and standards where those concerns, stormwater quality issues, groundwater quality. They're addressed by the standards that we have. I mean, that's the only thing I can offer up. There's a lot of things that we're not going to catch.
So I think
I just can't catch like a subdivision or
Right,
small
but rather
quarry.
looking at those individual projects or the permits that are being asked, looking at the water and monitoring what's going on with those 5 bodies of water. That's, rather than just monitoring how the water is doing. Wait, we've got too many houses in that area. No more permits for that. You are an environmental protection, not project protection.
No, I totally understand.
the problem we're facing up that area as a community is a lot of those projects that are a problem didn't go through subdivision. They just popped up. Those houses that popped up, that's why they didn't meet the stormwater management plans necessarily.
Some of those watersheds that are at risk are pretty high developed, and that's probably why they're on that list now. I mean, that's what I'm assuming. I'm assuming that I'm not even sure. I'm assuming if it's on a lake, if it's a watershed most at risk, that we have done at least some of the trophic states out there with Sicky Dish, see the water clarity, that kind of stuff. But there are, like I said, there are limits exactly what we can do at a state level. If there's something where you want to prohibit development, I mean, that's a case in front of the legislature, and then people says, hey, how do I do this? How do I do that? How did those lakes get on that list in the first place? I guess that would be my first question. What do you get out there now?
Well,
And most of the time, it's going to be residential issues, cluster developments, those sorts of things in that watershed.
and the department can't not issue a permit for something that meets the standards. I mean, the application in question here came in across my desk. I reviewed all the setbacks. I reviewed everything, and it met our quarry standards. So I can't deny them the permit based on the standards I have in front of me.
The way it would have to work for us is if you had a watershed that was particularly sensitive, that meant that an applicant had to use this specific set of BMPs for that design. And granted, BMPs are constantly evolving, but if that was the conclusion of the department, the only way you can make this work with this design is to use these BMPs for buffers to be this big, to do this, to achieve this detention time. And if the applicant says, well, I can't do that, then it's either you can't do the project as designed. You have to do something different.
And in this instance, also the zoning allows for, the town zoning allows for this operation to be on that property.
We don't look at, unfortunately, obviously that's a local issue, how you zone, where development fits in and where it doesn't fit in. That's certainly a local issue. The state doesn't look at that unless it's in the shoreline zone, because our guidelines, we review your ordinances, but we don't look at zoning. That's typically not a criteria that we're looking at. But it's a question. How do you, if there's a water body at risk or a river, stream, or brook? I certainly remember what the rivers looked like in the 60s, the Androscoggin. I remember exactly what that looked like in the 60s.
Well,
Straight pipes.
I am curious what other lakes has something like this.
Oh, I can probably come up. I bet you I have a lot of mining operations within watersheds most at risk.
When you say a lot, what's that?
I'm thinking of Sabattis. I can think of Sabattis Lake right now. I'm thinking that's a watershed most at risk, and I have. It's all
surrounded by gravel
it's
pits.
surrounded by gravel pits because it's a sand and gravel aquifer. You got the towns there with the town garage, you got the town sand salt pile.
Got all the
you got the farms there. But we got a lot of mining going on. But the big contributor for that load of pollutants in the lake is basically agriculture. So it's I know I'm not making you feel real comfortable. Probably I'm just kind of looking. We do have. The situations here with watersheds at risk in Wyndham is probably no different than other parts of the state that have watersheds at risk that have similar types of development.
Are there any areas that have just said no, that you can think of that have just said no more development in these areas around watersheds, or is that kind of uncommon? Or
I'm trying to think of some towns that have just outright banned or different types of industry, or you can't do things.
There's several moratoriums
across
the state, in Hancock and Lemoyne. And
we have one.
You have one.
You guys have one.
You have one. Edenton had one, but I'm just trying to think if there's been like an all-out prohibition. I'm quite sure if you went through with the town attorney or the CEO, even
Actually,
you, Amanda,
Cumberland.
Cumberland might
Cumberland
doesn't
outright
allow gravel pits.
doesn't allow gravel.
But you might be able to check with the Maine Municipal Association because they probably have a really good idea of what other towns have for local ordinances. And I got to be honest with you, the only local ordinances I typically look at are mining ordinances. So the town will call me up and say, "What do you think of this?" You know, we're just looking at consistency and what we see out in the field, what our experience has been to give you the heads up. I told you about the Stop Work Authority. I mean, I got probably a handful of things I can tell you. You make sure you want this, 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 and this, and the ordinance got to have that. You're going to find yourself in trouble. So, and I can give you that list too. You know, fuel storage. You know, what you catch and what you don't catch. But I would definitely check with the Maine Municipal Association, and hopefully that will help. Is it Jean?
Regan?
Regan. Why did I get Jean out of Regan? That's not even close. To see how that works, because I certainly understand her questions about if you have these water bodies, how do you make it not any worse? I mean, do you stop everything? You know, do you not fertilize your lawns? Do you not? I mean, there's all those things because you could stop development, but the water quality could still get bad. Mm-hmm. Because it's all the existing uses that are around that water body now. So it's kind of like it's a give and take kind of thing.
We as lakefront property owners have been working very hard and very diligently to clean this lake up. So when we see the overlay and it just has us in there at this point, it's kind of frustrating.
When you say overlay, help me out here, Amanda.
Our discussion last week had to do with adding an aquifer overlay in proximity to Forest Lake, and the overlay is where the aquifer is mapped. So that's why it wasn't. The discussion was based on where the mapped aquifer was, not a larger area.
Yeah, because I mean that when you look at like an aquifer overlay, I mean it's essentially okay. Where do you find sand and gravel pits? In sand and gravel. Where do you find aquifers? In sand and gravel, because you have high porosity. I mean, if you flip this chart over here, it's pretty easy to see. You got a lot of storage capacity in sand and gravel. This one right here. You can see sand and gravel. If you looked up in that area, well, some of your watersheds are similar. I talked about Sabatis Lake, and that's all sand and gravel all around it, so you can see it. And obviously, you got a lot of porosity. You got a lot of open space that stores water. There you go. There's your aquifer. So,
and it's important to keep in mind, looking at that map, that if you're trying to protect that significant aquifer, that's part of a much larger sand body that doesn't necessarily meet the specific statutory criteria that the Geological Survey uses to map it as significant. So, looking at that together with a surficial geology map of that area or a soils map of that area that talks about what are the sandy soils or the ice contact, what's called the ice contact deposits, that those significant aquifers are part of. If you're thinking about, well, how do I protect that? Those are areas that, in all probability, are contributing to that significant aquifer, or at least are physically connected to it in some way. Whether they're hydraulically connected becomes a different question, but certainly the area that potentially could impact water quality in the sand and gravel aquifer, in the mapped significant sand and gravel aquifer, is not limited to just that area that's on top of the mapped sand and gravel aquifer.
Yeah, it's you got a lot of trying to think for sand and gravel aquifers. I'm thinking your commercial district is pretty much all sand and gravel, isn't it?
Yeah.
Yeah. Oh, yeah. There it is. I mean, it's a huge outwash plain right there along 302 as you go from, I don't think I call that Wyndham Center, but it's where all your development is heading North Wyndham. Thank you. Heading up to Raymond and Tasco, and you can see how big that area is there. So, and I'm thinking of, some of your watersheds here are all surrounded by sand and gravel aquifers. I mean, it extends.
Right, because Little Sebago, Big Sebago, lakes most at risk from new development, sand and gravel aquifers
Yeah, and you
between
go
them.
west on 35. You go to Standish. They're blessed with a lot of sand and gravel. Up 114 on the west side of Sebago Lake. I'm thinking down if I head to South Wyndham down River Road, right? Isn't that on that map, River Road?
Yeah.
There's a bunch along. What is that? The Pasumscot River too. That's a lot of sand and gravel aquifer stuff down there. I mean, I'll give you an idea of all the licensed sites that I have. 55% of the licensed operations in the state are on significant sand and gravel aquifers. Okay, less than 3% is on what I would call a high yield aquifer, which would be, and it's just a number. I think MGS uses 50 gallons per minute, and it's just the idea is that definition. Correct me if I'm wrong, John. Is based on one, can you get the water out? And two, is it usable? Have I got that?
Yep.
That's how they define what an aquifer is. You got to be able to, one, get it out of the ground, and two, you got to have enough quantity with a volume. So, so that kind of the sand and gravel stuff goes hand in hand with gravel pits. Like I said, 55%. I did that number years ago. It's pretty easy, and you can call it right up on. If you go to that Google Interactive map, you call up the licensed sites. And on the table there, you can actually click on sand and gravel aquifers, and it will show you where everything is. You can pull up Wyndham. I can look at the map. I think I was looking at your zoning map. I could see the names. I mean, the names look familiar because we've been to most of those operations. So it's really it is hard. How do you a lake that's has a water quality? I mean, like I said, it could get worse even if you stop everything, because it's what's happening right now with the existing uses there. What do they contribute to that water quality of that particular lake? I mean, it's pretty developed around some of the lakes. I'm thinking the one in question here, I'm thinking is pretty highly developed on the west shore to the north shore, correct?
So right below.
And then when
the project.
Before you come into it, I think you're in the is that the Cumberland side? That's all sand and gravel right there.
I'm right in the middle of it.
Yeah, and then
Lots of old gravel pits.
And on the south side of Blackstrap Road in that area, I mean, that's all sand and gravel. That's like the old Blue Rock pit that was converted into like a commercial area now. And that extends down. You can see it when you drive down the turnpike.
Mm-hmm.
So sand and gravel banks when you come down the big hill, coming out of the, I think it's the gray service plaza on both sides. And it's pretty flat too. You can see it. So that's a tough question. As far as, how do you stop stuff? It's like you might have no development there, but your water quality could still deteriorate because of the existing uses there and whatever practices are. I mean, if it's all developed with houses, say you got 400 houses and you got 275 gallons of fuel tanks for each house, and how does that play? We respond to a lot of home spills, failures of tanks and stuff. Yes.
It does seem that there are a number of organizations that have tested water, like in terms of Highland Lake, they have a number of years of data, and we're seeing stability with that water. And then once development entered into that area, then we're seeing that those waters are now becoming endangered or have pollutants. So I know that we're getting better, that we're doing the work, we're putting the effort into it. But my concern is that when you have the large subdivisions coming in, you have 30 plus houses, that you're going to have that impact. So we already know that with those subdivisions in place, and after that point, we're starting to get healthier. So with a quarry coming into that space, it won't be good. And so we're trying to stop and fight all of the development on James Way at this point in time to prohibit that. But we already have the numbers, we have the data, we have the testing, and we have that evidence from Highland Lake. And so I think that information will help support us moving forward so that we can continue to work towards a healthy lake. And I'm wondering what types of standards that we can put into place. I mean, I understand what standards that we have in place with DEP and the state, but I'm wondering what can we do as a community? Are we hopeless at this point in time, or will lab results help us in some way to take this fight on?
You guys can chime in and help me out here. I'm trying to think. for water quality. I mean, I certainly don't work in the lakes monitoring program, so I'm not sure what we have for data on some of those lakes. That would be a question for. I did speak with Wendy Garland. She came down to see me. John McFedrin. He's kind of like the aquatic plants guy for invasives. I don't think JD didn't come down to see Jeff Dennis. He's kind of the phosphorus guy. You know, it's hard. I mean, you go out and the idea is to a lot through education, through the stormwater conservation districts, those kind of stuff, getting that information out to people. But what activities you do impact water quality. I mean, that stuff goes on every day. It starts at the school level too, through some of the stuff that we do. I don't have any specific water quality stuff. I mean, as far as I'm looking at Highland Lake, so it's a trophic state issue, I'm assuming, if it has algae blooms. John?
Yeah, I'm not that familiar with it.
Yeah, I'm not familiar with that one, but I know of some of the other lakes that kind of have that green look. China Lake, obviously, is the poster child.
Weber Pond.
Weber Pond, Togus Pond. There's a bunch of them that have algae blooms with phosphorus.
Sebatis Pond.
Sebatis Ponds, that's been green since I was
Didn't Lake
that
Island
big.
have a bloom? Killed all the fish off?
They had something.
They had something.
And that's
yeah.
the water supply for Lewiston. So I don't know. I'd have to think about that and get with other folks. I mean, I'm not sure if I can really give you a specific
Well,
answer for
I
that.
think those are there. I think it's known that that's the issue is phosphorus in Highland Lake and likely in Forest Lake. And so I think the idea, though, at least for regulating mineral extraction operations, though, does meeting the stormwater standards, I mean, you've said it several times, is not worsening the water quality of the surface water. We recently, though, it's for the closing the gap between smaller projects that don't require site plan and subdivision review to meet stormwater standards in our own local ordinance, that we've have single lot development that have to meet stormwater BMPs for any improvement that they do to their lot, with the idea being that that will improve water quality within the Highland Lake watershed. It's something the town could consider in the other watersheds of lakes that are at risk from new development, but I think we're trying to think of what else could we do if there's concern about the impacts for quarries and gravel pits as far as lake water quality.
I have some quarries that are licensed that have to meet the phosphorus standards. So you have the export value, and they calculate what their export value is. And typically, we've had rock quarries do whole rock analysis just to see what we had for phosphorus-based minerals in the rock. And the couple that I'm familiar with, one was the Vanna Quarry in Washington.
Yep.
They did a whole rock analysis because we were trying to figure out
Manifold?
Vanner.
Vanner Quarry.
V-A-N-N-E-R.
V-A-N-N-E-R, which is not active anymore, by the way.
No, because the rock wasn't suitable for use.
And a lot of money, and you think you spend money to figure out if you got the right rock quality before you license something. That's just where I would go. Do I have good rock to make good aggregate? So it's kind of fun.
In particular with that one, they went through and got a variance to externally drain and go below the water table. And they got into it a few years in, and the rock
quality
doesn't meet spec. So it's
went down.
unusable. So
Millions of dollars out the window. But we looked at phosphorus there, and we actually looked at a whole rock analysis. When I say a whole rock analysis, is actually they test the rock for what do you have? What constitutes this rock type? So we were looking for phosphorus, phosphate kind of bearing minerals to see what we had, because we were trying to figure out what do we have with this. This is the phosphorus standard for that lake watershed. This is what we got, because it is different. And I think it was the export was way lower off the top of my head for that particular site, because each one is unique. So it's a case-by-case analysis. That's how that goes with the review process. I can't sit there and say every site has to have 4 pounds of phosphorus expert a year. It depends. All those numbers are different for each and every lake watershed in the state, and they change depending on what the development is.
Yeah, because it gets to what are the sources presented by each type of development, and with quarries and gravel pits, we have a certain amount of freedom to make those internally drained. That we have made it easier for the applicant to get through the process if they can keep those internally drained. And if you're thinking about runoff as the source of pollutant to a surface water, that's the easiest way to deal with that. We quarries and gravel pits, we would not necessarily want to see that on commercial developments. We know that it creates a terrible groundwater pollution problem when commercial developments try to infiltrate everything on site. But that's the nature of that type of development. With a quarry or gravel pit, we have certain specific isolated sources, most of which we deal with through the spill prevention and spill response programs. And other than that, if that's internally drained, then the things that would be exporting phosphorus are retained within the site, and that's just not a material that's mobile in groundwater. And again, there certainly is fuel storage issues. There certainly are explosives handling issues. During reclamation, there are issues obviously related to are they using a fertilizer to encourage plant growth, and we would deal with that as part of the reclamation plan. But if you are requiring these to be internally drained, you have gone a long way to basically eliminating that part of the discharge to surface water. Then you do have the access roads, you do have the truck traffic, but access roads are fundamentally camp roads. They're wider. Obviously, they may be built to different specs, but it's a big gravel road. Truck traffic is an issue, but you have truck traffic over the high yield part of the aquifer on 302, and we deal with that by other means. I'm sorry, we had a question over here.
Ken.
Do you already have testing results in terms of the rocks from this area? Do you have also any type of results around any damage or impact to water sources from that rock? Or is that something that happens during the quarry project itself?
There are, and I have a recent analysis, oops, not that one, but I do have a paper here from 2010 that's a very comprehensive look at what we do, these whole rock analyses from the Sebago granite body and the surrounding rock itself. Whole rock analysis literally is just that. You take a rock sample and you crush it and essentially break it down into component oxides and look at what percentage of each mineral is there. To my knowledge, this did not sample anything specifically from this site.
Including silica?
Including silica. Yes. And remember, this is what's there. What's there is a tiny fraction of what's going to be present in the water. So you're looking for the minerals that are present in granite. If you get to an equilibrium solubility, you are looking at a few thousandths of a gram per liter that will be present in it, and that's at equilibrium. The other thing to remember is these dissolve really slowly. So if you're thinking about what percentage of that will end up in runoff or in groundwater, if the issue is how soluble are these minerals, the contact time of that water with the mineral is very short compared to the amount of time required for enough of that mineral to dissolve that it's reached its sort of maximum concentration per liter. So the primary export would again be if they are exported as a particulate and can get into a water body. Again, if you're dealing with it as internally drained for as much of the project as you can, and then access roads or other areas are handled through the appropriate stormwater BMPs that are appropriate for the sensitivity of the watershed. Certainly the municipality is free to make those more restrictive if it wishes, but the idea of internal drainage for these types of developments we think is an extremely useful way to go where it's feasible. It's not feasible everywhere.
So I know it's 7:30. The rest of the committee is good. I know we had a lot of questions on silica. Do we want to move on to some conversation around silica? I think, Regan, you had a lot of questions when we were talking last about
As a dust particle?
as a dust particle.
That's correct. I know that the trucks will be rinsed, and that water runoff will be addressed through stormwater management. And also the roads, if we think about the impact of a car or a truck going over that road, there will be runoff. But I'm wondering about the inhaling of silica, specifically as trucks go past school children. There are over 30 children in that area. They'll be picked up and dropped off at different times during the day through bus transportation. A lot of these children could have additional health problems, asthma, and our children today are not the healthiest of children. And so thinking about the children who may be latchkey children who could be walking maybe 1 mile from a bus drop-off location to their home. So thinking about the length of distance they'll be walking as well as their exposure to the air in that vicinity. Could you talk about how the air pressure is, the waves? I mean, you just mentioned that a moment ago with the energy of the waves that are passed through the air. How is that also impacted in terms of the pollution or the silica that could be inhaled through the airways as well?
Well, let's kind of look at it as a general kind of issue with particulate matter, dust from a gravel or quarry operation or somebody sweeping a parking lot. Okay, you get dust generation. We do have standards that allow certain particulates. I mean, it's based on air emission standards. The opacity. That means how much light goes through the dust cloud, and is it below a certain level for 5 minutes? So we go to smoke school. So we can look at dust clouds and say, what's the opacity when we go out to these sites? Most of the sites, all the sites that have processing, that's the key, the sites that have processing typically have some type of water suppression system to keep the dust down. As far as like silica, typically it's the actual worker on site that has the most risk. I mean, typically with like granite cutting, curb cutting, that kind of stuff, and you have equipment that's specifically designed, measures to prevent so the worker's not exposed to inhaling stuff. They could have a respirator on. It could be isolation, like in a cab of a front end loader or in a drill rig. It could be with vacuums, like with the drill rigs. They typically have a dust collection system, so it isolates the operator from the dust, sucks it up. It filters out the dust and then drops it down in the pile. So, and obviously it's a labor standard for silica. So most of these sites that have processing equipment, they have the Department of Labor comes in. It's actually the Mine Safety and Health Administration. And what they typically do for workers on site at aggregate quarries, gravel pits, is they'll put a meter on somebody's neck for a whole day. Somebody runs around with a meter on the neck all day long. They take the meter off. They go analyze that to see what is in there for particulate matter. And there's a threshold. So, I mean, most of those standards are based on for worker safety directly at the site where you are physically over whatever is being cut. As far as dust from like access roads, it's typically your BMPs, water, calcium chloride. I mean, this time of the year, no rain, you can have a water truck out there every 5 minutes.
They're actually proposing that the road going to the access site be paved.
You can pave it,
and then 100 feet of.
You still have to sweep it, because you're going to track stuff out.
We're asking for
it's like any dirt road. I mean,
tarping,
that kind of stuff. I mean, I've seen spray irrigation stuff that's triggered when a truck comes in. Calcium chloride lasts a lot longer. There's other types of dust control methods out there, not just calcium chloride, that you can use. But like I said, with the silica thing, it's mostly on-site worker safety through MSHAR and obviously National Institute of Occupational Safety. They have standards as far as what you breathe. And we have, I have some quarries out there that actually cut granite blocks and they make curbing out of it. And they have specialized equipment inside because they cut the rock at the quarry and they transport it to the facility on site with big saws to cut rock. And I mean, everything is just vacuumed. Why? That's for the worker safety. So there's a bunch of measures there. So same with noise. I mean, you have silica with little dust meters around their necks. Same with noise, because there's certain thresholds for hearing that for occupational safety you have to meet. There's a meter that they put around operators, and they use that all day, and all that information is taken back. So we typically don't do that. I mean, I'll do noise measurements, but it's noise at property lines. I'm not looking at noise for workers' safety. I'm looking at noise for our standards at property lines or a protected location. Dust, I'm looking, my test is really simple out there. I can do the smoke test, but if I'm eating grit for supper, I know you got a problem. That's what I tell my operators. If I'm eating grit for supper, because you can feel the grit in your mouth, you got an issue. Yeah, I've been in some gravel pits before that, you're doing this because you can't see anything in front of you. You can't see anything in back of you because the road is so dusty. And that's when you pick up the phone, you call the big cheese and say, you got to do something because I don't dare to move because I don't know what's in front of me and I don't know what's behind me. And next thing you know, the water trucks are out. But it's really hard, especially if you're in a drought situation like we are now. Dust is really tough. I get dust complaints in April. Why? You get the cold northwest wind. We have a dry spring. To me, April is really tough. It's worse than late summer sometimes because you get those cold winds that blow out of the northwest at 35. You can put water down and it's gone 2 minutes later because the wind just evaporates that right up. So you use your BMPs. I mean, it's anybody that lives on a dirt road. Is the road? Do you guys calcium chloride any of your roads around that particular lake watershed? So is it pretty dusty in the summer?
Mm-hmm.
Depends on how fast you're going too, right?
I'm usually walking.
Oh,
that's why I'm so raspy.
That's even worse. It's like being on a bicycle on a dirt road and a big truck goes by. It's not fun.
Now,
you can't see and you can't breathe.
On that note, when there's a blasting and that fly rock can go 1,000 feet, that road is well within that 1,000 feet.
Absolutely. That's why the idea is to design it so it doesn't go 1,000 feet or 500 feet. The idea is, the standard is you have to keep it on the blast site. Okay, and the blast site's actually defined as 50 feet around each loaded hole. So there's really not room for error. So when we're out doing an inspection, the first thing I'm doing when I'm walking that bench is I'm looking behind me and in the woods, and I'm looking to see if I see fly rock. Angular rock. I mean, if you see something angular in the woods, it's like, okay, that was recently blasted. Or if you look and you see an impact crater.
But of course, you're not going to see that until the project is well within.
Actually, you can see it through the video too. I mean, when you look at a video when a shot goes off, you can see the rock going straight up in the air. I mean, I have camera pictures where you look and you're like, oh, there it is, and then you go back to the site and you see it all laid up across the road, and it's like, you had an issue. Let's figure out what you did. Is it a timing issue? Is it a stemming issue? John talked about fractures. I mean, I've seen some fractures. It was actually pretty cool. It was maybe 6 inches thick, but it was like it was all ground up rock in the fracture. So when you grabbed it, it really felt like toothpaste. That's what it really felt like. But it's a seam that's not competent. So when you load it with explosives, it's just going to go. That's why you try to stem what he was talking about with the driller and the blaster, what zones of weaknesses that you have. Fly rock is something that operators and the blasters do not want. So there's great care taken. There's a science to blasting. It's not just out there and hit the plunger.
Most operators.
It's a true science. Are there accidents in time? Yep. I'd said probably a half a dozen in my 29-year career at DEP. I think fly rock's probably the worst out of anything. But it's really based on design. And if it's a good blaster, they're looking at all the information. They're looking at the video. They're looking to see how the rock breaks, which direction it goes in, that kind of stuff. So it's not like you're going to be walking down the street and you're going to get picked off by fly rock. Because I can guarantee if something happens or if there's houses that are impacted, I mean, I think the most recent incident I ever had was usually there's a call list. The blasting company will call. We're going to shoot at 2 o'clock. This is your 15-minute kind of notice. Please go inside your house. I had one company shoot 30 minutes early after they did the call. So the people were out in the yard, and there was an incident. So and that was a bad case. I mean, that's I have to tell you, that's an automatic enforcement case. I mean, if somebody's shooting rock at somebody's houses, you certainly have an issue, and that's an issue that they don't want, and certainly the department doesn't want. So
we've heard there's probably not a lot of it's a pretty specialized field, right? So there's probably not a lot of blasters around. Anyways.
No, there are not a lot of blasters.
There's one left, isn't there?
Two. You got Atlas Powder. You got Main Drilling. I mean, you had McGoldrick, but that's really Main Drilling now because they got purchased by by Main Drilling. So those are the big companies, and you have some smaller companies that do like foundation blasting, trench blasting for like sewer lines and stuff. Construction, of course, we don't catch that. Okay, we only catch blasting at the state level if it's a licensed quarry or if it's a site law project. Other than that, we don't catch blasting. And John had mentioned earlier that the fire marshal has rules about the transportation of explosives, the use, and storage. So that's a different state agency with the fire marshal's office.
I have two questions. Going back to the silica. One, do we have a significant amount in Maine? And two, you mentioned the monitors on the operators and so forth. If you could, I don't know if you have some rough estimate of how much of that actually would be on the trucks or whatever leaving the pit, if it's significant, you know.
I don't have that information. I'm assuming there are studies out there that have done that. I mean, obviously the closest impact would be the person, again, closest to where the dust source is coming from. A lot of stuff is dispersed through the air. Obviously we have granite. What's the most common element on the Earth's crust? Silica.
30 to 50%.
Yeah, silica. There's silica in everything. There's silica everywhere. You know, I haven't even looked at statistics. I think you could probably go to the CDC about silica, but most of them are with the types of industries where there's some kind of cutting, you know, jackhammering, milling pavement, that kind of stuff. And it's usually
things that would generate very, very fine particles.
Right.
And that's why something like the sawing is a much greater potential source than blasting, say, which will throw up a certain amount of dust, but that's just kind of dust. It's not fragmenting it. So the particle size that's on a truck probably is pretty representative of the rock composition as a whole. It's the silica that we're generally talking about here is as quartz, and that's, you know, by the nature of granite, you're looking at 30 to 50% quartz. If you look at the whole rock numbers for the Sebago granite, they all run sort of below 70%, 71, 72, 70% as silicon dioxide. Now, it's important to remember that silicon is present in a lot of other forms. And just the way the chemistry breaks down, it gives you a result as silicon dioxide, but not all of it is present as something that would be free silica. Much of that is bound up in other minerals that would not necessarily be an issue for free silica. It would still be a particulate issue, but it wouldn't necessarily be relative to silicosis. But a granite, by definition, is going to have a large percentage of silicon dioxide as quartz, which is the major issue. It's what is the process that's generating particulate that's sufficiently fine that it could get into the air and become an issue for silicosis. And those are generally going to be the things that will generate, like the sawing, like the cutting, like the jackhammering, that generate lots and lots of very fine particles. Blasting by itself won't do that.
Okay, that's interesting. Thank you.
I had a question along those lines, just as far as your experience with complaints related to that kind of dust. That, I mean, having a better understanding of the blast versus other operations is helpful, but would it be more from truck traffic? Obviously, environmental conditions must play a part, but I mean, based on other setbacks you have from property lines and whatnot.
I think what I would call, based on inspection results, I think the big three is traffic, dust, and noise. That's typically what we get the complaints on. And we don't regulate traffic. Okay, that's if it goes over a certain traffic count, it's a part of the DOT. We do regulate dust and noise, though. So typically what I have seen, it's mostly with access roads, typically in dry months of the year where you have dust generation from truck traffic coming in. So.
Regan, did you have another question?
Trying to remember. Prior to, I'm just trying to. Oh, I remember now. Okay, I want to go back to again the water quality and stopping development. Again, I feel like there's a lot of it might get worse even if you don't do anything different, just basically because what it is going, what it's doing is even if we don't do anything. So let's just take a gamble and see what happens. I'm not 50, but let's say hypothetically I am 50 and I got 1 foot in the grave. I don't go and kill myself as a result of that. So what I do is I try to extend my life by eating healthy and doing yoga and all of those sort of things, trying to get joy in my life. So I try to do what I can to extend my life. And I mean, I would hope that that's what you want to see your grandchildren grow and so on. So going back, looking at these bodies of water that have the potential to get worse, certainly they could, but we take proactive action to protect what we have and to make decisions that contribute towards healthy water. So again, I wonder why it is that the DEP can't set up a new standard or better standards to be proactive to help people like us who are concerned about the water that we have near our homes. It seems ridiculous that we can't be proactive in that respect. I mean, certainly anyone could drop dead tomorrow, but we all try not to.
Yeah, I'm hoping for another 30 years, to be honest with you. Again, I mean, something to that extent. I mean, it's just we as a department certainly cannot come up with something without the legislature's involvement. It's really that simple. I mean, we just couldn't come up with something that says you can't do this. It's a deliberation at the legislature where they make the statutes for us. I mean, that's really
go for it and go to legislature.
That's the clearinghouse. It's just anything that we do for rule is through statute and the other governing bodies. So we could come up with a great idea and go to the legislature, and you could come out with something totally different than what you went in with.
Yeah.
So I mean, it's that kind of trade-off.
It depends on what a program is designed to do. So if a licensing program by its nature applies a set of standards to those things that meet the statutory criteria that say you need a license to do this thing, and if it doesn't meet all of those statutory criteria, it doesn't come in to meet those standards. What I think you're talking about is something that's much more comprehensive than that, that's looking at overall development within a watershed. And certainly you can say abstractly, if we could say no new development in here and we are somehow going to improve the development that's already there by decreasing the amount of impervious area and cleared unrevegetated area and upgrading stormwater BMPs. Could we abstractly say that that would probably lead to improvement or at least no degradation in the water quality that we have in that watershed? Well,
Were you guys aware of the wetland just south of this?
Yes.
You are.
Yep.
It boggles my mind.
Over it that would need to get expanded for their trucks, but that's not on the property.
Right. That's Forest Lake Road, isn't it?
Yes.
Yeah. Yeah, I have lots of operations.
No, this is Lakeside Drive.
Lakeside Drive. That's it.
Forest Lake.
We have
a corner.
Yeah. Yeah. We have lots of different operations with wetlands, streams, vernal pools, wading bird, waterfowl habitat, you name it. We've got sites licensed all over the state that have stuff like that all over. So, I mean, the idea is, say, if they were doing below the water table, we would look at the impact to see if that wetland would be dewatered. So, to go below the water table. The idea is, standard says, you got to avoid and minimize. So that's for any project. The idea is to avoid and minimize wetland impact. And if you do impact wetlands, how much do you have? And then there's mitigation measures that you take. It could be, preservation somewhere else. It could be compensation fees. Same with, using urban impaired standards for stormwater. There's compensation fees for other work in the watershed to improve the water quality. That's how that whole stormwater system kind of works. So there's lots of different stuff. So I'd love to give you a straight answer with Regan about why can't we, but it's really as John said, what type of program you have and what is it geared to do. And if you want to do something different, a lot of stuff is just change of behaviors, man. It's really that simple. Smaller driveways, smaller houses, less lawn, no fertilizer, don't use chemicals. Go organic. Pave all your roads, then you don't have dust.
Don't have septic systems.
Using roof line drip lines for all old houses. So when stormwater comes off your roof, it infiltrates right there instead of running off. So there's all kinds of different things, but there's like that change of behavior stuff, which obviously I can tell you that the mining program wouldn't catch that. Mm-hmm. There might be something else out there.
It's much more of a sort of a local watershed comprehensive plan than it is a mining specific activity.
Yeah. What do we do for these lakes?
I think we had one more kind of just general topic that if you could talk about kind of these accessory uses. You mentioned them, like people processing asphalt and cement and something sort of, is that a variance from your rules, and how do you give consideration to those?
It's not, but I mean, typically with most aggregate operations, you're going to have some type of process and equipment because now all the standards have changed for road designs, for septic. Septic, you need washed stone, so you got to wash stone in a quarry or a gravel pit. So everything typically mined out has to be processed. The days of bank run are typically gone unless you're putting just gravel on a camp road.
I like to explain it as even with asphalt and concrete and the standards, like the bedrock in Washington didn't meet standards. The DOT has very stringent standards now. Like you just said, you're not doing bank run gravel anymore. You're creating a designer product to meet the specs that you require, and that involves crushing and processing and things of those nature.
So you'll see a bunch of different stuff. If it's just sand and gravel, you see screens. If it's kind of a bony gravel, you have a rock crusher. You could have a cone to break it down. So first thing is a jaw crusher, takes rock this big, makes it maybe this big, then you get a cone that makes it, 3/4 of an inch, half inch, 3/8. If you got a rock quarry, you're going to have a series of crushers on site. Because they're not going to usually transport the rock off site to crush, because that adds a substantial cost. I mean, you won't be competing with anybody else if you're taking it from point A 10 miles down the road to process it. That's just not going to be, the economics won't be there. A lot of times, larger facilities will cite these other facilities such as asphalt plants and concrete plants because they use large volumes of aggregate. So you may see that. If an asphalt plant goes into a licensed gravel pit, we get to look at it. We'll look at dust. We look at fuel storage. We look at all those things. If it's a asphalt plant that's down the road by itself, we might not look at it because it may not trigger any law to be looked at. But if it's in a licensed pit, we look at it. Same with a concrete plant. Those are typically the two. You might see a wash plant, like concrete sand. Typically, all the sand is washed. So you'll see grip ponds associated with that. And when I say grip pond, it kind of looks like a sediment basin, but they're built as a closed loop where the sand is washed. It's trying to get all the fines out, so you have a clean sand for like bedding for pipe, that kind of stuff. And each little area of the grip pond, if you got really dirty water, and then it goes to the next one, it's fines are knocked out, and then you get to the last one. They're recirculating the water back through the process, so it's a closed loop system.
Retention time.
Yeah. Yeah. So you'll see grip ponds. I'm trying to think of. Do I have any close by here for you? I can't think of anything in Wyndham. Do you?
No.
I think the last. I think the last ones are Blue Rock on Blackstrap way back.
Right.
But I can't think of anything here. But I can, in Poland, For Pike, I mean, they have a huge facility, crushing plant, asphalt plant, rip ponds, you name it. They get
Shaw
some.
and Gorham doesn't have asphalt?
No.
Not Grip Ponds, no, but
No, Shaw
so it
Brothers?
just had asphalt.
Oh, yeah, they got a huge asphalt plant right there at the main office with a brand new crushing facility. Yeah, I just recently licensed that one.
Shah Mahal.
Yeah, it's really well done. That's done. But I mean, it's you're gonna have those types of processing facilities in there. So we look at fuel storage because you're looking at asphalt plant. You're looking at
Liquid asphalt.
which is that doesn't go very far once you take the heat out. It congeals instantly. It's like diesel fuel. So you're looking at that. You're looking at 20,000 gallons. So you're looking at the design for SPCC. How's it designed? Is it 110% of the largest tank on site? Is truck traffic going over the lines? Those sorts of things. So a lot of it's really
Does precipitation accumulate in the containment area? If it does, how do they get rid of it?
yeah. It's not like you can just pump it out. If you see a sheen on the water, you gotta have it vacuum pumped and taken to a facility that treats that. So and we look at that stuff. Best time to do an inspection is when it's raining. Then you can see where water goes.
So
Does that help you out with crushers and stuff? I mean, you got a lot here in Wyndham. I mean, you can go to the Shaw Brothers. I mean, the grinding quarry up off 302. They only process in there when they blast. They don't blast.
They haven't blasted
They
in
haven't
like
blasted
6 or 8 years.
They haven't blasted there in a long time.
Actually, you guys have a project for Copart putting in parking areas there.
We just talked about that before you got here.
Right.
Yeah.
But I was involved.
That's in the old gravel pit area, right behind.
That
I think
has
it
a
would
wading
be-
bird habitat that was mined prior to the rule.
Right.
So essentially, they
Is
can
that
develop
behind?
in that habitat but can't expand into it.
Is it
That's a whole
Jeunesse?
different-
Jeunesse is in there.
Jeunesse
Yeah.
is in there.
Yeah.
Lumber yard.
Lumber. So that's changed quite a bit. So those are the typical things that you might see. And I had pictures of all that stuff. I mean, it could be a baby rock crusher that does 100 ton an hour. It could be something way bigger that does
Like Shaw Brothers.
500 tons an hour or 1,500 tons an hour. Asphalt plant, it can put out 300 tons of asphalt an hour. So it all depends.
too bad Danny's not here.
Yeah.
Danny Shaw's on the committee. usually.
Oh, is he? Is he on this committee?
And Tim Tamberg.
Actually, I will say that when we developed the performance standards back 25 years ago, back in '93, Dan Shaw was on the committee. Phil Grondin.
That was in Tim's pit last summer. Actually doing an
I'm trying to think
inspection.
of who else. There's a bunch of Doug Foglio. There's a lot of the large operators. Blue Rock was there. Tilcon was there at the time. So, it was a give and take relationship. As well, we all sat down, we looked at standards and said, hey, because I remember what the legislature said to us. They said, if you guys can't come to an agreement, we're going to come up to an agreement that nobody likes. So,
And that's how the notice of intent to comply process
we,
was. Because prior to that, you needed engineering plans, groundwater studies, surveys. Like it cost you $250,000 just to open up gravel.
and it was years before they got permits. So they went to the legislature. As I said, they went to the legislature. So there was a bunch of bills back in, that was 1993. Remember that?
Yep.
And we asked, why do we have to be on the committee? We were trying to get our boss to be on the committee. But he gave it to us, guys.
That all predates
So
me.
I think we're
Yeah, it does predate you.
I say we're right at 8 o'clock. So I'm gonna have any additional comments, questions you guys want from the.
Do you want us to send comments? I'm sorry.
Yes.
Reagan?
Thank you.
Yeah, we have. I did look through some of your ordinances, and I did see some discrepancies. So didn't Eric? If we put those into email and get them back to you, Amanda, would that be okay?
Yes, that would be helpful.
Fantastic.
Thank you.
I had some questions going. Okay, here you said something. Here you said something different.
I might also suggest that, some towns in their ordinance, it's like the shoreline zoning ordinance, they just adopt the state's ordinance as part of their town. So one possibility here is you guys could adopt our performance standards or the department's performance standards as part of your ordinance.
Yeah, I mean,
We have
the ability. It's just like shoreline zone. If you want to delegate authority to take over the state's program, you could apply to do that. I can tell you right now, there's not one municipality in the state that's taken over the state program in 25 years. Most towns will develop their own local municipal ordinance dealing with specific things that they have in the town. You'll see like the the body of the state performance standards in there, but there may be other sections of that performance standards that were tweaked by the municipality based on concerns. Like
I think that's essentially the approach that we're attempting to take.
So you see that stuff in there. So I'm thinking of Hancock. They did a bunch of stuff in the past. Lemoyne, Eddington. I mean, I've looked at a lot over the last
Sanford.
25 years. Sanford. So there's a
Sanford's
lot.
really
But
strict.
I definitely would check with Maine Municipal. Can kind of give you an idea. So
Yeah, and anything you guys can send us that you see, like you just said, that'd be great.
yeah, we can do that.
Okay. So I think we're at the end of our usual time.
Yeah,
So I think
if
we'd
you
like
want to just send your comments to me, or we can
Already
PDF
scanned
that.
this in.
Um,
You did?
I have
PDF
this
it to
scanned.
me?
I think we need to
Can we-
hold off and come back on
table the other items till next time.
to talk about the aquifer. I think I'll bring you some more maps just so we can look at it. John's suggesting
yeah.
kind of that soil, the additional superficial geology, just to talk about kind of an area outside of the mapped aquifer. But I did want your confirmation tonight just about that schedule for a public forum for September 20th, if that still worked for you, because we'll prepare notices.
I think so. Looks like a
Yep.
yes.
Okay.
Sounds good.
Okay. We'll table the other stuff till next week.
Yes.
Okay.
That
Okay.
was good.
Thank you,
That
Mark.
was-
It will be in here in
That's
council
your
chambers.
area.
Yes.
The only place it's really allowed would be here.
All right.
Thank you guys for joining us tonight.
Thank
We
you.
greatly
Very much
appreciate it.
appreciate
Thank
it.
you.
Very informative.
All right. Good. All right. Thanks, everyone.
All right, we'll send you that information. It was what? Inspection report, process and equipment?
Yep.
If I might send it to you just as a PowerPoint. Because we do have, I could have taken you right through from the get-go. But I didn't do that. I figured it'd be a question and answer kind of thing.
Chris Hansen doesn't take part in these?
Yeah, no, but I met Chris on site.
Hi.